Assalamualaikum, my name is Nur Sabrainda binti Muhammad Sobri, metric number B09181049. I am from 3BMMMM S1/1. My supervisor is Professor Maria IR Dr. Muhammad Hazli bin Abu Bakar. Today I would like to present about effect of laser engraving parameters on surface morphology and quality on copper plate. Research objective. The main objective of this research is to analyze the effect of laser engraving parameter on surface morphology and quality on copper plate. Specifically, the objectives are as follows. First, to evaluate effect of laser engraving parameters on surface morphology and quality on copper plate. Second, to evaluate the effect of laser engraving parameters on surface and quality metals. Third, to analyze the quality of laser engraving on copper plate. Next slide is problem statement. The purpose of the research is to analyze the effect of laser engraving parameter on surface morphology and quality on copper plate. Technology evolved according to the passage of time. Same goes to laser. Laser engraving can be used on hard and durable materials such as steel, aluminium, plastic, galvanized and more. Some of the company provide high price for a low quality of the engraving. The quality of the engraved surface is a significant aspect in practical laser engraving application. Next slide is introduction to laser. Laser is a device that causes atoms or molecules to generate light at a certain wavelength and then amplify that light, resulting in a very narrow beam radiation. The emission usually only extends to a small visible spectrum, infrared or ultraviolet wavelength. Many different types of laser are being created, each of its own set of properties. Light amplification by stimulate emission of radiation is what laser stands for. A laser is an unusual light source if compared with flashlight. Laser produce a very narrow beam of light. This light commonly used in many technologies such as optical disk drive, laser printer, barcode scanner and so on. Laser is an artist tool where laser engraving can be painted on anything by using light and heat to burn the surface of the canvas. Laser engraving also offers varieties of benefits such as non-contact method, which means the laser is not physically touching the surface of the material, instead relying on heat to achieve the desired result. Laser engraving is known as highly efficient because it's safe to change from material to 16 other materials. Actually, laser engraving is considered safe because can be conducted from computer that is far away from the object itself. Electrons, in particular glasses, crystal or gases, are stimulated and from a laser when they absorb energy from an electrical current or another laser. This electron moves from a lower to a higher energy level as it travels around the nucleus of the atom. Lasers, unlike light, have only wavelength and need a single shade. A laser produces a narrow beam of light with all of its speed aligned that travel together. This is the only reason laser beams are so narrow, brilliant and can be concentrated into such a small area. Laser beam can travel great distance because laser light remains focused and does not spray out as much as a flashlight. It may also focus a large amount of energy in a tiny region. Next slide is example of laser engraving. Laser engraving can be used as a fabric such as denim and leather are well known as material for laser personalization in both the cutting and straightforward sector. Due to their incredible precision, laser can be carved even the most complicated design into a variety of materials. Next is QR code. Most industries such as the automotive, medical technology and electronic industry already employ line and tool codes similar to serial number to make items or individual parts traceable. The codes carry information on the part qualities, production data, batch number, and much more. Component labeling must be easily accessible and, in certain cases, electrically accessible, as well as permanent. Laser marking appear to be a useful tool for a broad range of materials, dimensions, and sizes, as well as the processing of dynamic and changing data in the sector. Parts are laser marked at the maximum speed with the greatest precision with the least amount of wear. Each product bears serial number in form of 2D code. Last, jewelry engraving. Personalization jewelry is in fierce competition nowadays, with users seeking producer to manufacture one-of-a-kind product that are customized to their requirement. This would have been a time-consuming and expensive process in the past, but with the help of fiber technology, customization, new component, or adapting existing element that never been better. From etching private message on the inside of the ring, can be used laser as a ring engraving machine, to adding significant time frame to laser engraved jewelry that will be chosen to wear for a special occasion. Fiber laser solution empower customer and authorized producer to give their customer more access and control. Next is type of laser. There are 3 types of laser which can be classified as fiber laser, gas laser, fiber laser, and liquid laser. First, let's go take a look at gas laser. Carbon dioxide, or known as carbon dioxide laser engraving, is an efficient method for material removal in small scale. It's developed by Kumar Patel in 1964. The laser is created in a sealed glass tube filled with gas by a carbon dioxide laser. A high voltage is applied to the gas particle in the tube, which interact with them and increase their energy, leading in creation of light. Secondly, fiber laser. Fiber laser is widely used in industrial field because of its great ability to cut and engrave. In 1961, Elias Neisser introduced the fiber laser, which he demonstrated in 1963. Only in 1990 did serious commercial product arise. The active medium of a fiber laser is an optical fiber doped with rare element. The reason for this is that this earth element at top level has extremely useful energy level, allowing for the use of a less expensive diode laser pump source while still providing a high energy last output. Last but not least, liquid laser. Liquid laser have a gain medium that is a liquid at room temperature and are optically pumped. Dye laser are most effective of all liquid laser. In these years, the various energy state of organic dyes immersed in liquid solvent are used to generate broadband laser light. Due to their performance, tunability, and excellent coherence, dye laser are useful for scientific, medical, and spectroscopic research. Furthermore, because of their broad discharge, they are especially well suited to producing ultra-short laser pulse. Next slide is laser parameter. The laser parameter can have an impact on the material removing rates during the engraving process. Some of these factors can be tweaked or modified to improve the laser process quality. Laser power, engraving speed, frequency, and loop count, and wavelength are some of these characteristics to be considered when laser engraving process are done. Copper plate. Despite copper has a drab reddish brown tone, if a glossy, more appealing finish is is required, it may be brightened with the addition of chemicals. Since copper is a soft ductile metal, it's suitable for plating surfaces, an item that requires some elasticity. There are various benefits of using copper as a workpiece, such as copper is a great conductor and work really well in conjunction. Next, copper can be bonded with silver or nickel plating. Furthermore, copper is also being used in medical field due to its resistance of bacteria. Methodology. Material selection was choose for this experiment is copper plate. Method selection, laser engraving is used to carve on the carbon plate. Specifically, fiber laser engraving. Parameter choose. Variable parameter are tested on the copper plate in order to get an optimal result on this experiment. Performance measure also done by doing surface roughness testing on the material to determine which parameters suit the best for copper plate. Next slide is flowchart. A flowchart was created with a goal of providing an overview of the laser engraving process from subject selection through project execution to analysis and evaluation of results. This flowchart was created to provide an overview of the laser engraving process, beginning with a literature review, followed by performing experiments, evaluating the result, and ultimately discussing the finding. Expected results enable the characterization of surface after being lasered at specific parameters. In addition, the appearance of the surface demonstrates the selection of which best surface for product making. The roughness of a surface is critical from a practical engineering standpoint. Surface roughness allows designers to evaluate the accuracy of process component by predicting variables such as the amount of friction or vibration produced between two contact surfaces. Summary. Lasers are utilized in a variety of disciplines including medicine, welding and cutting, as well as communication. When compared to traditional engraving technique, laser engraving has a number of benefits, including no tool wear, high automation, free programming, and character selection. One of the most important factors driving the development of laser machining technology is its ability to produce exquisitely precise machining as well as complicated form and machining of different materials such as metal, wood, polymer, ceramic and leather. That's all from me. Thank you.